If you understand how vertex form works in the equation of a quadratic function, then you can create an equation for a function when you don't know it if you have the graph and you can identify the vertex. So let's take a look at that with an example. First off, a little reminder. Here we have vertex form. F of x equals a, the leading coefficient, times the quantity x minus h squared plus k. Remember that the vertex here would be given by the constants h and k in this form. So let's look at this particular graph. The vertex is this lowest point, and it's at a location of -2, -5. So that would be my h and k. So I can go back up here to the equation and put in the vertex. Remember, a is not part of the vertex. We still need to find it. So I'm going to have x in parentheses minus a -2 for h. Don't forget that's minus the h value. That's all squared. And then the k is -5. So instead of just adding a -5, I'm going to say just -5. So simplifying this, we have f of x equals a times, now a negative would be x plus 2, quantity squared, minus 5. So I've plugged the vertex in. Now I still need to find a, but it turns out if you have a graph and you can pick out any other point on the graph, you can solve for a. I'll give you an example. Now it's better, we have an infinite number of points, but it's better if we pick out a point that's easy to read and has whole numbers or integer values. For instance, the y-intercept here is a really easy point to pick out. It's at 0, -3. Another point you could easily see would be this point at 2, 3. We want to look for points that are on the crosshatches of the grid so that we have whole numbers or integer values that are easy to calculate with. What we're going to do with one of those points, and I'll just use the nicer one because the y-intercept has 0 and 0 is easy to calculate with, is that we're going to plug that into the equation. Now we're trying to find a, so a stays a. This 0 is the x value in this point, and -3 is the y value. So I'm going to put 0 in for x, and I'm going to put -3 in for y. Now remember, f of x is just another way of saying y. So here I have an equation with now only one variable in it. If I simplify and solve, I can figure out what a is. So simplifying, -3 is just -3, but over on the right, 0 plus 2 is 2, squared is 4. And then I have the -5. To solve for a, I need to add 5 to both sides. So I'm going to get 2 equals a times 4. And that 4 is multiplying, so just divide it on both sides. So we get a equals, now be careful here, this is 2 over 4 or 1/2. So a is equal to 1/2. Sorry about that noise. My computer was bringing up something it wanted me to do, and it made a noise when it did that. So a is 1/2. So we can plug that into the equation and have the full complete equation. F of x equals 1/2 times the quantity x plus 2 squared minus 5. This is the equation of this graph. Now we can check that by graphing it, by putting it in Desmos and making sure we get the same graph. Or the other thing is we've got multiple points here we could check with. In fact, I haven't used the 2, 3 yet. So let's just do a quick check with the 2, 3. If I were to put the 2 and the 3 as a point in, as a check, I'd be putting the 3 in for f of x, because that's the y value, equals 1/2 times 2 plus 2 squared minus 5. All right, I need to simplify that. 3 is still 3, 1/2. 2 plus 2 is 4. 4 squared is 16. Continue calculating on the right. 1/2 of 16 is 8. 8 minus 5 is indeed 3. We actually have checked that that other point on the graph did work in the equation we found. So finding an equation for a quadratic function, if you have the graph and you understand vertex form, isn't too bad.